Welcome to this explainer, everyone. If you're a focused learner looking to finally bridge that gap between writing basic background scripts and building dynamic, truly interactive web tools, well, you're in the exact right place today. We're going to take a deep dive into the absolute anatomy of a custom application. We'll be exploring exactly how to architect district web apps using Google's HTML service. So get ready, because we are going to break down how professional interactive tools are built from the ground up, all right here within the Google ecosystem. Let's do this.
Okay. Let's dive into this. Here's a quick look at our roadmap for today's explainer. First, from scripts to web apps. Then, the brains in the face. Next up, front to back-end flow, followed by securing the Agua Fria district. And finally, deploying and managing tools.
All right, section 1, from scripts to web apps.
So right off the bat, we've got to acknowledge a pretty common problem. Our district needs are rapidly outgrowing those simple everyday scripts. Now, if you've been scripting for a while, you already know the power of trigger-based scripts, right? They're absolutely fantastic for automated background tasks. But let's be honest, they have a pretty limited interface. A lot of our district needs require something much more interactive. Just picture a teacher filling out a form and boom, they immediately see a generated lesson plan right there on their screen. Or a counselor who searches for a student and instantly views their progress data in a really clean visual dashboard. Or maybe an administrator reviewing pending capstone submissions and approving them with just a single click. These rich, interactive experiences, they demand instant user feedback. And moving from a basic background script to a dynamic web app using HtmlService is exactly how AppScript delivers those experiences.
And this brilliantly illustrates what we call the literal front door to these dynamic apps, the doGet function. Every single AppScript web app starts with doGet. Basically, when you deploy your script as a web app, Google hands you a specific URL. The second someone visits that URL, this function is called automatically. Inside this function, your script actively generates an HTML page and zips it right back to the browser. So from the user's perspective, they're just using a normal web application. But behind the scenes, your script is doing all the heavy lifting.
Moving right along to section 2, the brains and the face.
Now that we're actually inside the app, we need a solid way to organize our code. When moving into HTML and AppScript, an easy way to think of it is this. The code.js file is the brains, and the HTML script is the face. It's really that simple. The brains handle all the heavy logic, the data access, reading from sheets, making those API calls. The face, on the other hand, is entirely about what the user actually sees, what they click, and what they interact with right there in the browser window. Now, to keep those brains and the face cleanly separated, we rely on a very specific method inside our doGet function, and that's HtmlService.createTemplateFromFile. Look, while you certainly can generate simple static pages with basic HTML output, this template approach is absolutely the best pattern for any tool with real complexity. Why? Well, it lets you keep your HTML, the face, in a totally separate file from your code.js brains. This separation is a total game changer. It makes your code highly readable, incredibly easy to debug, and so much simpler to update when you just want to tweak the look of the app without, accidentally breaking the core logic.
Okay, let's jump to section 3, front to back-end flow. Let's move to and see how this builds, because you might be wondering, how do the brains and the face actually talk to each other? Well, the key connector, think of it as the nervous system between the user's browser and our server, is google.script.run. AppScript gives us this special JavaScript object exclusively for front-to-back-end communication. You just drop it into your front-end HTML file to seamlessly execute a server-side function located in your brains file. And because it's an asynchronous call, which basically just means the browser doesn't totally freeze up while waiting for the server to do its thing, you can attach success and failure handlers to tell the app exactly what to do when the server finally responds.
Let's visualize this invisible flow in real time. Picture this. Step 1. The user clicks a button on the face of the app. Boom! This triggers an on-click handler. Step 2, that handler fires off google.script.run, sending an asynchronous request flying over to the server, passing along any necessary parameters, like maybe a student's email address. Step 3, the server-side brains take over. They securely read from a master sheet, filter the data, and return the results. And finally, step 4, the dot with success handler back on the front end catches that returned data and dynamically, instantly updates the face of the app with the new results. It's incredibly fast and totally seamless from the user's perspective.
And here is exactly why this specific flow matters so much. Notice that the sheet access happens entirely on the server side. The raw master sheet data is literally never exposed in the user's browser. So the user gets this really smooth, snappy, app-like experience, but all that sensitive district data remains totally protected behind the scenes. The system only ever passes the specific, filtered bits of data that the user is actually authorized to see.
Which brings us to Section 4, securing the Agua Fria district.
Now, what's really interesting about this slide is how these deployment settings are absolutely essential for district tools. First off, you set the app to execute as me, which means it runs using your builder permissions. Second, and this is the critical part, you limit access exclusively to anyone within the Agua Fria district. Why is that so crucial? Well, setting access to district users is essential for security because it instantly leverages Google's bulletproof native authentication. Users are literally required to authenticate with their official district Google account before the app even loads up. This guarantees that only verified staff or students are entering. Plus, you get the massive benefit of never, ever having to invent, build, or maintain a custom login system, which, let's face it, are notoriously vulnerable to security breaches.
And because you force that strict, district-level authentication right at the door, you unlock the absolute power of this single line of code in your server-side brains. Session.getActiveUser.email. Once they're authenticated, you can pull the exact email address of the person using the app. This right here is the foundation of user-specific data. You can take that email, look it up in a secure Users tab on your spreadsheet, retrieve their specific progress or permissions, and then display only the appropriate content. It creates a highly personalized experience for every single teacher or student, totally automatically, the very second they open the app.
All right, last but not least, Section 5, deploying and managing tools.
Okay, so now that we've actually built and secured this app, we need to push it out into the wild. Now, I know one of the biggest fears when building tools is breaking something that people are already actively using. But honestly, AppScript handles this beautifully through its versioning system. When you deploy a new version of your app, the underlying code, your brains in your face, is updated on the server. But the deployment URL, it doesn't change at all. This should totally reassure every builder out there. Users who have bookmarked your app's link will continue to access it at the exact same address, seamlessly getting all the new features or bug fixes without ever hitting a broken link.
Let's just summarize the mic drop reality of this whole technology stack, which, by the way, fits perfectly into the builder's permit design philosophy. By using HtmlService, you require zero external hosting and zero server maintenance. You don't need any confusing DNS configuration. These apps integrate completely natively with the Drive, Sheets, and Gmail tools your staff already use every single day. And arguably the best part, these enterprise-grade, highly secure district web apps can be totally managed by a single certified builder without tying up your entire IT infrastructure team. It's just a completely self-contained powerhouse.
So there you have it. You now understand the anatomy. You know exactly how that Doogit front door works, how to cleanly separate the brains from the face, how they communicate asynchronously, and how to lock the whole thing down securely for the Agua Fria district. The tools are literally right there in your hands, and the barriers to creating incredible user experiences are completely gone. So I'll leave you with this one final thought. Now that you have the brains in the face, what will you build for your district? Thanks so much for joining me on this explainer, and happy building.